section to cover after this, so maybe trying to not go too fast. So okay, everybody ready to do the assignment now on page 83, number 1 and 2? Just two questions, Bruce. Number 1 and 2. Okay, 6. Alright, so when we're talking about distance from 0 to number line, we talk about two possibilities. And that's because you might have, like the negative side of the number line, that's the distance to 0, and the positive side of the number line, that's the distance to 0. So most of these have two possibilities. But on Friday, I didn't really have a chance to get you these notes over here about special solutions. So if you want to take a minute and write this, you can write it under your notes from Friday, or you can write it with your bell work today. These are the special things that come up, and there's one of them in bell work, and there was a couple of them in your assignment. So it needs to be noted that this is special solutions can only be determined after absolute value bars are isolated. So when I look at number 1, 2, and 3, Libby, so which one doesn't have the absolute value bars isolated? Which one has something complicated going on to start? Number 3 does. That's because of that number, that -4. And I'm sorry, this is toolbars covering it. If I can see that good, I would mark it down. But there's a -4 here in the front. So this one isn't isolated, but these two are. So you can only figure a special solution out after the absolute value bars are isolated. So anyway, if you go to your expression in the bars, it's less than a negative number. There's no solution. And that's because distance is not less than a negative number. Distance is always positive. So if the bars are there, there's a less than sign, a negative number, that's go ahead, no solution, it's impossible. However, if you have an expression in absolute value bars and it's saying greater than a negative, well, that's always true. The bars will make anything positive, and a positive number is always higher than a negative number. So for that, you say it's true for all real numbers, or you say it's infinite solution. Same thing. And then number 15, I think in your assignment, it's like there's a 0. Be real careful about zeros, is what I have to say. Sometimes there's just like it's everything but a number, and we'll talk about that in 15 today. So the 0 is actually a little more complicated. So for number 1, there's two possibilities. If y is greater than 4.5 from 0, that's what it says. Y greater than 4.5 0. Here, bro, if you need to move, you can. It's really hard to see over there. There's an open seat all in our permanent open seat in the back of this store. Okay. So my two possibilities is I'm going to drop these absolute value bars. And first I will keep everything the same. And then I'm going to do it again. But on the second possibility, I'm going to flip the symbol. And I'm going to change the sign. Change the sign of the number. Flip symbol and change sign. It's a full review of everything I said. Anyway, I got y is greater than or equal to 4.5. I dropped the bars. And over here, y, I'm going to flip the symbol, make it less than, and I'm going to make the 4.5 negative. Question so far? So on a number line, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I would do closed dot because it's equal to. Okay, this tells me y is higher than. Sorry, this isn't really good. Should put it on the card. Anyway, this tells me y is numbers higher than 4.5. So I'm going to go to 4.5 and I'm going to point to numbers that are going higher. You think about what you can put in here that make it true. 6 is higher, 10 is higher, 20 is higher. I want all the numbers that are higher to be graphed. Whereas this one says y is lower than negative 4.5. So I think about what numbers are lower. Here's negative 4.5, and I point to lower. Get your arrows right. Did you get your arrows right when you did it? You got them right? Did you do the infinity sign? No. So let's do an infinity sign for that. So on the left side, I have negative infinity up to negative 4.5 bracket. I'm going to move this podium. And on the right side, I have 4.5 positive infinity. Hopefully you can all see that now. And now ask a question since you couldn't see before. So the higher is over here, 4.5 and higher. Bracket infinity. Bracket negative. All right, number 2 has 2 possibilities. Maybe we're just going to keep everything the same, drop the bars and keep everything the same and say that 9 minus 4n is less than 5. But then we're going to do it again. And we will flip the symbol, change the sign. 9 minus 4n is greater than negative 5. And I'm going to pause now because I'm going to look around the room. Half of you haven't done it yet, at least. I know a couple of you have, but half of you have not. So I'm going to wait. Do one or both. Do a number line. Do an infinity sign. Okay? I think probably 7 of you have it done. That's not the majority. So if you feel like you understand this completely and you're sitting a little bit bored, you can start reading 1.6 if you want. fractions or something? Decimal. Let's make it a fraction. Okay. I'm gonna subtract. Oh, it's 7/2. Okay, I'm gonna subtract, and I get oh no, -4n is -4. Now, right now, this goes back to remembering Algebra 1, which you could have done very easily in Algebra 1, but don't remember now. When you divide by a negative, you have to flip the symbol. And I think that was in the sign somewhere. So this is actually going to be n is greater than 1. Subtract 9 over here, and I end up at -14. The same thing's going to happen. Even though I set out my problem, it's already flipped. I'm flipping it again. Divide by -4. Now I'm going to flip the symbol, and I have n is less than 7/2, or 3.5. You got the 3.5, good job. Right here, I'm dividing by a negative number. Changes like the nature of the number, and then it changes like which way the arrow goes. So I flip the symbol, lots of flipping. Okay, so this is what I have. Numbers that are higher than 1 and numbers that are less than 3.5. I'm going to do an open circle this time since we're not equal to. Check it out. It meets in the middle. Instead of going opposite directions, it meets in the middle. So I had one arrow going left and one arrow going right. They're meeting in the middle. And I actually I can predict that when I look at the problem. When I looked at this one, it says y is greater, and greater kind of means like far away, right? Like distances far away. So greater, as the problem begins, I'm picturing the arrows going far away. It's greater. But this one says my distance is close. My distance is less than 5. My distance is little. It's less than. So for this one, I'm picturing my arrows coming in, close to 0. Okay, so you can foresee which way the arrows are going to go for a lot of them. Did you do your notation? So since they meet in the middle, we don't need infinity signs. We're going to go from 1 to 3.5 or 7/2. This is required, this interval notation. Starts at 1 and it goes to 7/2. Alright, this one. This problem is not ready. I can't do anything yet. It's not ready. It's not set up correctly. You gotta put some work into it to even start the problem. The work I gotta put into it is right here. This -4. It's gotta be canceled out. The -4 is crowding the absolute value. You have to move it. I can't say move. I mean, that's what we're doing, but I can't say it. I'm gonna cancel it. Cancel that -4. So it's multiplication. You don't distribute in. Don't distribute into bars. It's multiplication. I'm gonna divide. Just to get the problem ready. Alright, I'm dividing by negative, so I'm flipping the symbol. This whole bit says it's greater than -3. Are we gonna believe this? Is this absolute value going to be greater than -3? It's for sure going to be greater than -3. It's always going to be positive. Think about if you plug in 10 right now. 10. That's 60 minus 8. 52. Is 52 greater than negative 3? Yes. What about negative 100? Can you guys do that in your head right now? What would negative 100 do to this? That's negative 600 minus 8 is negative 608. Is that going to be greater than negative 3? The bars are going to turn it greater than negative 3. So whatever's in here, it doesn't matter how negative it gets, the bars are going to make it positive. It's always going to be greater than negative 3. So this is going to come out positive because of the bars. So we're going to say this has infinite solutions. Or more technically, you could say this works for all real numbers, just not the not real ones. I can put any real number in there, and it's always going to work. It's always going to be true. And you should sit and question that when you're getting bored in class. Be like, how could she just say it's every number? And try some different numbers. That's what you should do when you're bored. Try to figure out what these words mean. Who's got a good question? Make it at your homework. 1 through 17 odd. Here's the answer and work for 1 and 3. And there's 579. wow, here's 11. Yeah. Okay. Here's number 13. Get into a larger problem. Lots of work should be shown. Anybody have a question about what they're looking at 13? They're showing the work here a little different than I do. They put it right in the middle. That's shorthand for doing it in two different problems. This is the equivalent of flipping the sign and making the result negative. But I used to teach that way. Students, very much express they prefer just doing it this way every time. It comes out the same. All right, here's 15. I feel like I maybe did this in one of the classes, but when you think about absolute value being greater than zero, it's kind of a perplexing situation. Like by definition, the absolute value of expression is greater than or equal to zero. So this inequality is true for all real numbers, except for those that make it exactly zero. So they're looking at one would make it exactly zero, and they're excluding it because exactly zero is not greater than zero. So it's like f can't be 12 because the distance wouldn't be greater than zero, it'd be exactly zero. So there's like a full graph, and there's just an open circle at 12. That's counted. I'm not going to put like that on the test or anything. Tricky one. The rest of these are fair game though. And there's 17. Because in the SAT, that's something the SAT would want to challenge. Do we have a question about any of these? Okay. Let's turn your textbooks then to page 78. Or 77. I want you to look at the title of the section. You are supposed to do this with a partner, and some of y'all are like, you're looking really sleepy. It's a Monday, so if you want to get up and move and look at it with a partner, we don't have long. Like, I'm gonna do this like 2 minutes. We have 2 minutes to discuss this. But I want you to think about what the situation is in real life. What is a digital wallet? And then why would this be called a piecewise function? Why is the title piecewise? What might you call it? And why do you think they called it piecewise? So feel free to get up. You can move to a friend. Say, I don't know, and then go sit down. That's fine. But if you need to get up and move around right now, talk, you can. You're falling asleep. Don't have long. 77. Right. What do you think, Lewis? Why do you think they called that piecewise function? Why do they call it a piecewise function? Oh, got the actual definition. Look at it. In your words, why would it be piecewise? How many pieces are there actually, guys? 1, 2, 3. Yeah, it's in 4 pieces. All right, so they're calling this one function. It's all talking about one situation, but they got it broken down into pieces, so they're calling it a piecewise function. It's just a function that has different parts. The rate of change is not the same. You guys, what is a digital wallet? Yeah, what do we call it on our phone? You got your Cash App, you got your Venmo, you got your Zelle. That's what we're talking about. We're talking about our digital wallets. So they had 300. They made $50 in 2 days, $25 a day. They spent their money. They made their money again, and then from day 5 to 6, their money stayed the same. It's not the same rate of change forever. So it's broken into different pieces, piecewise function. All right, let's take a look at it. So let's look at that definition that Lewis read. And I was going to have you write it, but we don't have a ton of time. So if you want to just highlight it, you do want this to be known for your test. This is going to be a test definition of a function defined by 2 or more equations. When you do the PSAT or the SAT and you see this, it looks extremely overwhelming. There's so many symbols. But I'm going to break it down for you. Once you know what you're looking at, it's really not as complicated as it seems. So instead of writing the equation twice, they could have said y is x minus 2, y is 2x plus 1. Instead of that, they only write y once. They use the f of x symbol, the equal sign, and then they use this fancy bracket. But if you want to just think about it like y equals this one, y equals this one is fine. It's like two equations, but it's all on one graph. It's all part of the same function. So they just have one equal sign. It's just a shortcut. It makes it look complicated, but it's a shortcut. Now, this over here just tells you which part we're looking at. This isn't anything mathematical. It's symbols that they really should be using words to say. This says if x is less than or equal to 0. So if we were going to use words, we would say the left side of the graph. So over here, right, x is less than 0. And then for the other one, the bottom, where x is greater than 0, we would have said the right side of the graph over here. But they don't write out left side, right side. They say how x is defined. This is when x is less than 0, you're on this equation. And whenever x is greater than 0, you do this equation. Okay? So everybody take a minute, orient yourself to the symbols. This is just a shortcut, so we don't have to write y equals. And this is just a shortcut, so we don't have to say left side and right side. Let's take a look at what a question might look like. Let's look at number 1 here. It says evaluate, and then it gives us what? 1, 2, 3, 4, 5 numbers to plug in for x. So even though it's one question, you're plugging in for x 5 times. I would really call it 5 math problems. No, you don't do both. Good question. You only choose one to plug into. You don't have to plug into both. So for x equals -8, I'm going to plug it into the top. And for x equals -2, I'm going to plug it into the top. And for x equals 0, I would plug that one into the bottom. And for x equals 7/2, I would plug that one into the bottom. And for x equals 5, I'm going to plug that one into the bottom. Now, I didn't just pick. I have to plug it into either the top or the bottom. Does anybody know why the first two are the top, but the rest are at the bottom? Right. Because -8 and -8 is left of 0. Right? So the negatives that are left of 0, I plug into the top equation. Whereas these ones, boop, 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 they're all greater than or equal to 0. So you have to figure out which one to plug into, the top or the bottom. And if you look at number 2, there's even a middle option. So they can just make this as complicated as they want. All right, I want to shorten this, so I'm actually, for our purposes today, I'm not going to do these 3 for our notes. Okay, I'm just going to do the lowest and the highest value. All right, so x is -8. I'm going to do -3 times -8. That's positive 24. Done. And for 5, I'm going to do 2 times 5 plus 7. So I'm plugging in for x. This is just fancy notation. And that's going to be 10 plus 7, that's 17. You plug in for x and you do the math. All right, so right now on number 2, I want you guys to decide for x equals -8 and x equals 5, which one are you going to plug into? And then go ahead and do the math. Get a number out. So number 2, do -8. What'd you get? Oh, 3. So weird, right? When we put this into the top, it's weird. There's no x here, so you don't actually plug in. You just say f of -8 is 3. That's that constant function, a straight line at 3. There's no x, there's nowhere to plug in.
F of 5 is 7.
It's going to be 5 plus 2. So this one actually goes in the middle because 5 is right between those. So yeah, 7. F of 5 is 7. Feels a little bit like coding. I've done coding. Those inequalities and is actually a lot in programming. We've got a good question about how we decided the middle. How come we didn't use the bottom? Can anybody tell me an x value that should go into the bottom piece of the function?
6.
6. 5 only goes in the middle because of the equal to sign. But I questioned it like 3 times. Because 5 is not greater than 5. It has to go there. And so I keep thinking this one's higher than this one, but it's not. So 6 has to go here, 10, 12, 100, 3,000. Everything higher than 5 plugs in right here. Okay. All right. So I've assigned you 2 of these for your assignment today. But gosh, yeah, it's not just 2 problems in it, is it? It's 10 problems. What do you say? This is make a table. Is there a table in here? Are these people making tables? No. But you feel like you want to make a table. Do you have a table on your paper? Can I take this? Why are you trying it out? Don't you have 5 minutes? Try it out. You guys have 5 minutes. Try number 1. Don't hang up. Get the stuff out. You didn't show any work, really. I'm gonna need to I'm gonna need to see some work. Here's all the answers. That's a good job. I like your organization, but try to show some work, okay? I'll be here after school today for 30 minutes. Come on in, finish this assignment right in school. Okay, and leave here with no math homework. Now you have it right. Okay? Come on in after school. You're using your time, you're working till the bell, you're asking a question. Who's got a question? Ask